Hello and welcome back. Today we'll be doing question 2 from the 2015 math paper. Let's get started. Part 1. Expand and simplify a minus b, a to the n plus a to the n minus 1b plus a to the n minus 2b squared plus all the way to plus a b to the n minus 1 plus b to the n. Part 2. The prime number 3 has the property that it is 1 less than a square number. Are there any other primes with this property? Justify your answer. Part 3. Find all the prime numbers that are 1 more than a cube number. Justify your answer. Part 4. Is 3 to the 2015 minus 2 to the 2015 a prime number? Explain your reasoning carefully. Part 5. Is there a positive integer k for which k cubed plus 2k squared plus 2k plus 1 is a cube number? Explain your reasoning carefully. Pause the video to have a think and watch already restart to see if you were correct. Let's get started with part 1. Firstly, we'll multiply every single term in the second bracket by firstly a and then negative b. Then we'll notice that many of the internal terms will cancel out, and this will leave us with simply a to the n plus 1 take away b to the n plus 1. Now we'll move on to part 2. We're looking for a prime number that satisfies the form n squared take away 1. We can factorize this to get n plus 1, n minus 1. Now we'll set each factor to be alternately equal to 1, as this is what gives us a prime number. Firstly, setting n plus 1 equals 1 will give a negative number overall, and this is not possible for a prime number. Next, we can set n minus 1 to be 1, and therefore our number is 3, which is already given. Therefore, we only have 3 as a potential prime number of this form. Now we're going to move on to part 3. Firstly, we're going to rewrite n cubed plus 1 as n cubed take away the cube of negative 1. Then we can factorize it as above into n plus 1, n squared take n plus 1, and we're going to call this k. If we set n plus 1 equal to 1, then we have k is equal to 1, however that is not a prime number. Now we can set n squared take n plus 1 is equal to 1, and this gives n minus 1 is equal to 0, giving us n equals 0 or n equals 1. n equals 0 has been done above, but n equals 1 gives k equals 2, and therefore the only prime number that is 1 more than a cube is 2. Now let's move on to part 4. We can factorize the left-hand side into 3 to the 5 takes 2 to the 5 multiplied by 3 to the 2010 plus 3 to the 2009 multiplied by 2 plus all the way to 3 times 2 to the 2009 plus 2 to the 2010. Neither of these factors is equal to 1, since the right-hand factor is quite large, and the left-hand factor is 243 take away 32. Neither of them are equal to 1, and therefore the left-hand side expression is not a prime. Now let's complete part 5. Firstly, we're going to look at k cubed plus 2k squared plus 2k plus 1, and we're going to see that it looks suspiciously close to k plus 1 all cubed. That is equal to k cubed plus 3k squared plus 3k plus 1, and because k is a positive integer, this is larger than our expression. Since k is a positive integer, our expression is also larger than k cubed. Therefore, we have that k cubed plus 2k squared plus 2k plus 1 is between two consecutive cubes, and therefore it can never be a cube. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.